Math lesson number 15. Graphing linear inequalities in two variables. A linear inequality in two variables can be written in any of these forms. Ax plus by is less than c. Ax plus by is greater than c. Ax plus by is less than or equal to c. Ax plus by is greater than or equal to c. An ordered pair xy is a solution of the linear inequality if the inequality is true when x and y are substituted in the inequality. So let's have this example. From the set 0, -3, 5, 5, 1, -2, -3, 3, which of these ordered pairs is an element of the solution set of 5x minus 2y is less than or equal to 6. So meaning to say, we need to find out if 0, -3 is a solution of this, 5, 5 is a solution of this, and so on and so forth. Now, how do we know? So we need to substitute 0, -3 to the inequality x and then y. So we have here 5 times 0, that's because x is 0. And then 2 times -3 because y is -3. So that one. Simplifying that, we have 6 is less than or equal to 6, which is true. Therefore, 0, -3 is one of the solutions of this inequality. Next, we have 5, 5. So we have x 5 and then y 5. Substitute to the inequality. 5 times 5 minus 2 times 5 is less than or equal to 6. Simplifying, we have 15 is less than or equal to 6, which is false because 15 is greater than 6. Therefore, 5, 5 is not a solution of this inequality. Next, we have 1, -2. Simplifying, 9 is less than or equal to 6, which is also false. Why? Because 9 is greater than 6. Therefore, 1, -2 is not a solution of this inequality. Next, let's have -3, 3. So, substituting x, -3, and then y, 3, we have 5 times -3 minus 2 times 3 is less than or equal to 6. Simplifying that, we have -21 is less than or equal to 6, which is true because negative is less than positive. Therefore, -3, 3 is one of the solutions of this inequality. The graph of linear inequality is the set of all points in a coordinate plane that represents the solutions of the inequality. So meaning to say, in this example, y is greater than x minus 2, so the graph is this. This part is the solution set of this inequality, meaning all the points here will satisfy this inequality. Next, on this side, this shaded part is the solution set of this inequality. All the points here will satisfy this inequality. Meaning, when we pick one point, that's x, y, so we substitute here in our inequality, it will satisfy the inequality. Now, let's have the boundary line of a linear inequality divides the coordinate plane into two half planes. So meaning to say, when you graph this one, you have the upper part and the lower part. So you divided the plane into two. Only one half plane contains the points that represent the solutions to the inequality. Meaning to say, if this is the solution set, then this one is not. Only one half plane. Now, this broken line, why is this broken? or dashed, because this greater than has no equality sign. It is only greater than. Now this one is a solid line because this one has equality sign, or y is less than or equal to. So there is or equal to in the inequality. That's why it is a solid line. Now what's the indication of that? When we are talking about greater than only, meaning to say all the points here in this line are not part of the inequality. Unlike this one, all the points here are also the solutions of this inequality. Let's have examples. Number 1, graph 2x minus 4y is greater than 16. So first, for easy graphing, we need to convert or change 2x minus 4y is greater than 16 to slope intercept form. So we're going to do that. So this one, let's have this one. We need to isolate 4y. So 4y will be transferred to the other side. It will become positive. And then 16, because we need to isolate 4y here, so we need to transfer also 16 to the other side. So that one. This is the result. And then I'm going to interchange the position of the left and the right side. So we have 4y here on the right side, but the symbol will change, of course. No, it will become 4y is less than 2x minus 16. So take note of that. So from greater than to less than, because take note of the point. Okay, take note of the point here. It points 4y. This one, it still points 4y. Okay, so don't forget that. Now, after isolating 4y on the right side, we need to divide all sides by 4 because we need to isolate y only. So 4 divided by 4 is 1. That's y. 2x divided by 4 is 1/2 x. 16 divided by 4 is 4. So this will be the slope-intercept form. So it is easy now to graph this inequality because of this. Now we need to change that into equation. So we have y is equal to 1/2 x minus 4. And then we graph this using dashed line. Why dashed line or broken line? Because there is no equality sign being used. So this will be the result. So first, we'll consider the y-intercept, -4. That one, -4, and then 1/2 slope. So 1, and then go to the right, 2. So this will be the other point. So connecting that will be your line. Okay, that's the first thing of you need to do in graphing. Next, shade the half plane below. Why below? Because we use less than. So if it is less than, the graph or the shaded part is below the line. If it is greater than, the shaded part is above the line. So this will be the result or the graph of this inequality. Okay, meaning to say all the points here will satisfy this inequality. So that will be the graph. Now to check, let's substitute 0, 0, the origin, to the inequality. So 2x minus 4y is the original one. So 2 times 0 minus 4 times 0 is greater than 16. So that's 0 is greater than 16. 0 is not greater than 16. Therefore, it's false. 0, 0 is not a solution of the inequality as seen in the graph. So as you can see, 0 is not part of the shaded, in which 0, 0 does not belong to the shaded part. The graph is correct. So this one this graph is correct. Let's have number 2. Graph y plus 3x is greater than or equal to 5. So we need to convert this to slope-intercept form. So transfer 3x to the other side to isolate y. So we have y is greater than negative 3x plus 5. This will be used in graphing. So we need to change that to equal sign, equality sign or equation. Y is equal to negative 3x plus 5, and then we use solid line because of the equality sign in the original inequality. Now, we start with 5, that one, 5, and then the slope is negative 3, so you will be going up 3 times, 1, 2, 3, something like that, and then go to the left 1 time. That's it. So this will be the other point. So connecting that, okay, that will be your line. Okay, next, shade the half plane above the line for y is greater than or equal to negative 3x plus 5. Why above? Because we use greater than. Okay, so this will be the graph. All the points here again will satisfy this inequality. Now again, to check, substitute 0, 0, the origin to the inequality. So y plus 3x is greater than or equal to 5. So 0 plus 3 times 0 is greater than or equal to 5. 0 is greater than or equal to 5 is false because 0 is less than 5. Therefore, 0, 0 is not a solution of the inequality as seen in the graph, in which 0, 0 does not belong to the shaded part. As you can see, 0, 0, the origin is here, and this one is the shaded part. Therefore, the graph is correct. Let's have number 3. Graph y is less than or equal to 4. So as you can see, there's no x here. First, we need to graph y is equal to 4. And in graphing that, we need to use horizontal line pointing at pointing at 4. That one, horizontal line. So that's the graph of y is equal to 4. Then after that, since we use less than, we will shade the lower part of the plane. So that one. So this will be the shaded part. This will be the solution of y is less than or equal to 4. Now to check, we have 0, 0, the origin. 0 is less than or equal to 4, which is true. And as you can see in the graph, 0 belongs to the solution set. So the graph is correct. Let's have the last example. Graph x is greater than 7. First, graph the line x is equal to 7 using dashed or broken line. Why? Because there's no equality sign here. Just greater than. And then after that, shade the half plane to the right. Why to the right? Because we use greater than. So if the line is vertical, greater than means you need to shade to the right of the line. Okay? And then if it is less than, you need to shade to the left. Now to check again, we'll try 0, 0, the origin to the inequality. 0 is greater than 7, which is false. And as you can see in the graph, 0 is not part of the solution set. So the graph is correct.